Imagine a planet like Earth, but supersized, twice as big, heavier, has a thick alien atmosphere, and orbits a distant red star. This isn't science fiction. This is K2-18b, and the James Webb Space Telescope may have found signs of life there. Could this mysterious world be home to alien oceans? Let's dive in. K2-18b is a type of planet that scientists call a super-Earth. It's larger than Earth, but smaller than ice giants like Neptune. In particular, K2-18b is about 2.6 times the size of Earth and has roughly 8.6 times the mass of our planet. This makes its gravity about 1.7 times stronger than what we experience here. So if you tried to jump onto K2-18b, you'd probably just barely leave the ground, but the view would be out of this world. This super-Earth orbits a red dwarf star. It's a relatively cold star compared to our Sun. And here's the kicker. Despite its fainter star, K2-18b takes just 33 Earth days to complete a full orbit and still sits comfortably within the habitable zone. These temperatures would allow liquid water to exist. A sweet spot is a key ingredient for life, as we know it, but it gets weirder. Unlike Earth's nitrogen-oxygen atmosphere, K2-18b's atmosphere is dominated by hydrogen, a light gas that can trap heat and dramatically alter surface conditions. This hydrogen-rich layer could pressurize the surface incredibly, like the bottom of an ocean trench on Earth. This leads to an intriguing theory. K2-18b could be an ocean planet, a world surrounded by a thick hydrogen atmosphere and blanketed by deep alien oceans. In such an environment, the planet could potentially support an entirely different kind of marine life, thriving in warm, high-pressure oceans hidden beneath swirling clouds. Scientists predict temperatures here could range from negative 100 degrees Fahrenheit to 117 degrees Fahrenheit. Yes, extremes, but still within the possible range for habitability, especially when you imagine K2-18b with its insulating atmosphere. Imagine a water world orbiting a pale red sun, shrouded in dense fog larger than Earth, a mysterious distant cousin of our home planet that could potentially harbor life deep below its surface. Now things get really exciting. James Webb, the Space Telescope, recently detected dimethyl sulfide, DMS, in the atmosphere of K2-18b. DMS is a molecule that, as far as we know, is produced only by organisms that live on Earth. It is a byproduct of marine plankton, small ocean organisms that play a key role in Earth's ecosystems. So if this detection is true, we may have found for the first time a chemical signature that strongly suggests life on another planet. Consider this. A molecule linked to life has been found on a distant planet 120 light-years away, but the surprises don't end there. JWST also detected methane, CH4, carbon dioxide, CO2, and water vapor, H2O. These are all critical molecules in both biological and geological processes. Together, these gases point to a potentially active dynamic atmosphere, an atmosphere that could support some form of life, or at least complex chemistry. Water vapor is particularly important. Its presence suggests the possibility of a water cycle. So clouds, precipitation, and perhaps even vast oceans hidden beneath K2-18b's dense atmosphere. If that's the case, we could be looking at a veritable world of animals, a hydrogen-rich ocean planet with the right ingredients to support alien marine ecosystems, drifting through warm alien seas. Could there be alien plankton? Life as we know it isn't, but it's still life. These findings don't prove there is life out there. Not yet. But they give us the most tantalizing clue we've had yet. and they push the search for life beyond Earth into exciting new territory. Let's compare. Type of star. Earth orbits our Sun, while K2-18b orbit a red dwarf. This means more UV radiation for K2-18b. Atmosphere. Our atmosphere is made up of nitrogen and oxygen. K2-1b has a hydrogen-heavy gravity. Earth has 1 gram. K2-1b has an 8-hour clock. Oceans. Earth has salt water. K2-18b may have oceans rich in hydrogen or helium. Radiation. Earth is relatively sheltered. Red dwarfs can bombard planets with explosions and high-energy particles. So while K2-18b shares some potentially life-friendly characteristics, it also lives in a much harsher environment. Now, before we all jump on the alien life bandwagon, scientists are being very cautious, and for good reason. DMS signal detected by JWST is 100% not confirmed. There's still a possibility that what we're seeing is noise in the data or interference from other overlapping chemical compounds. No matter how advanced the instruments are, they can sometimes mislead us when interpreting faint signals from light years away. And even if DMS is present, it doesn't automatically mean life on Earth. Yes, DMS is a biological byproduct produced by ocean plankton. However, in a different environment, like K2-18b, it could arise entirely abiotically. Volcanic activity or hydrothermal vents could theoretically create similar compounds without the need for life. Let's not forget the environment we're talking about. K2-18b orbits a red dwarf star, famous for its explosions and high-energy radiation bursts. These could eventually erode the atmosphere or bombard the surface with harmful radiation. For life to survive, it would have to be extremely resilient or perhaps buried below the surface or under thick oceans. So yes, there's a lot of excitement, but there's also a lot we still don't know. This mystery is far from solved, and more observations are needed before we can make bold claims about alien life. Still, K2-18b is one of the most exciting exoplanets ever studied. Potential ticks many of the boxes for habitability, located in the habitable zone, has a thick atmosphere, shows signs of water vapor, and now possibly even molecules associated with life. This alone puts it at the center of one of the most important questions in science. If the James Webb Space Telescope confirms the existence of dimethyl sulfide, DMS, or other potential biosignatures in 2025, we could be witnessing a true paradigm shift. The moment we move from wondering to knowing that life beyond Earth is possible, a planet like Earth orbits a distant star. With whispers of alien biology, it almost sounds like science fiction, but this time, the science is real, and the implications are monumental. Could we really be on the verge of discovering that we are not alone in the universe? Stay curious, be inspired, and as always, keep looking up.